Okay. So today, here's our goal. We are going to pick up the other half of what we did not finish yesterday. Yesterday, we looked at samples and parameters. Today, or actually, we also did the mean absolute deviation yesterday, or what was abbreviated as MAD. That was at the bottom of your homework from last night. Today, we're going to look at what is called standard deviation. What's up? You'll use Desmos. So if you want to go ahead and go to the Desmos calculator, you can. And then you can kind of just hold there for a sec. So basically just take it, take it to here. And then you can leave it on a screen that looks like that for a moment. Okay. So it says here in statistics, the standard deviation is the measure of the amount of variation or dispersion of a set of values. So basically what we're saying there is when we find this statistic called the standard deviation, what we're ultimately doing is we're seeing on average how far each of our scores fall away from the mean. So individually speaking, yesterday it really wasn't individually speaking. Today, it's about how far does each one of them fall from the average. And so we're going to look at this a couple different ways. I actually took, of the 4 algebra classes, I took 2 of them and I wrote down all the scores from the chapter 10 test. Okay. And we're going to look at what's the average of those, and then what's the standard deviation for each one of those. And we'll talk about how that standard deviation plays into the results that we see. Okay? Because sometimes just hearing the average doesn't really tell you much about the total result, especially to more of like an individual level. So remember this part here. How far does each score fall from the mean or from the average? Here are the steps to finding the standard deviation. We're actually going to use the computer to aid us in the process of finding the standard deviation. Yesterday, when we did the mean absolute deviation, the steps looked very similar to this. If you recall, we found the average. Then we found out how far each value was away from the average. We added all those up and we divided by the total. And that gave us what we called our MAD, or our mean absolute deviation. All right. So, have you ever seen a picture that looks like this? May ever seen something like this? It's what's called a bell curve. All right. And here's what's really going on. Each one of these colored sections, so these 2 in the middle together, these 2 blue ones on the outside, and then again that lighter color of blue, they represent percentages of the total. Okay. When you talk about standard deviations, you're talking about how far away from the middle do I have to go to start to gain a certain percentage of the information? This symbol down here that kind of looks like a fancy O, maybe, that is the Greek letter sigma, S-I-G-M-A, sigma. All right, and it stands for the standard deviation. So you kind of make it like this, like the O from the Orioles. If you kind of thought like that's kind of how that symbol looks. All right, and it's the Greek letter sigma, so S-I-G-M-A. But what it stands for is the standard deviation. All right. When you find this value, and we're going to find it here in a second, what it's going to tell us is how far away from the average do I have to go in order to obtain 68.2% of all of our student data. If I only have to go just a couple units away from the average, then that means all my scores are relatively close together. If I have to go 10 units, 11, 12, 13 units away to gain that same percentage, it tells me that my scores are all over the map. Okay? So here's what we're going to do. We're actually going to jump this one for a second, and we're going to take a look at this right here. So we're going to hide the bottom one. Okay? So this is one of the 4 classes. It might be your class. It might be somebody else's class. You don't know that. Okay? This is not your class?
No, it's not.
What's that? You don't see your score? If you remember on this test, the score was out of how many points? was out of 50. Okay. So there are clearly 16 scores up here in this box. All right. So here's what we're going to do. First, we're going to find the average of this. Okay. Now we can find the average by picking up a calculator, taking all those numbers, adding them all up, and then dividing by 16. Or we can let Desmos help us to do this. Okay. And inside of Desmos, here's how you're going to do that. Over here in Desmos, you are going to hit the plus and you're going to open a table. All right. And in that table, we're going to input those values. So I'm going to bring this back up so you can see it. Okay. Yes, sir.
So how did you
Did you hit the plus button?
Yeah.
Okay. So pick. Oh, you're just literally going to type them in straight down the line. So just go ahead and take 20 seconds or whatever, and you're just going to type those numbers in. It does not. You got all yours in there yet, Aiden? She's telling you you're doing it wrong. So if I'm going to switch screens on you for 1 second, if you take a look there, you're literally just going to open a table and you're going to type them straight down the column. He was doing it wrong. Hey, this isn't a sellout period. Just get your values in there. All right. We need to get those 16 values into that table. The order doesn't make any difference. So whether you want to go up and down or left to right, I prefer you don't try to go diagonally. That would get kind of confusing after a minute, I would think. All right. Everybody got them in there? No? So you want to make sure you have 16 values. We good? Okay. So here's how Desmos can operate this system. If you go down to the next equation bar there that you can enter, so if you click and put your cursor in what would probably be box number 2 for you, and you pull up the keyboard at the bottom of your screen. I'm sorry. Geez, my screen over there is frozen. Jeez. Sorry. Okay. So click down here in box number 2 and then pull up your keyboard at the bottom. And over on the far right, you have a button that says functions. There are 4 categories. If you click on the second one that says stats, then if you look right there across the top right corner says mean, which would be our average. If you click on that, the word mean will show up in your equation box number 2. And you just need to simply put in there what we're going to put in there is that we're going to put in X1 because that is the title of the column that has all of our information in it. So inside of that mean, if I put in X1, I will get an answer of about 44.4. Are you with me there? Okay. Now, in the next one, so if I just click down to number 3, I'm going to do the exact same thing, except this time I'm not going to choose the mean, but staying in that third column over there, the third one down, STDEV stands for the standard deviation. So I'm going to click that one. And then again, inside the parentheses, I'm going to put X1. Okay. You with me so far? All right. So what I've got here is I have a standard deviation value of 5. Here's what that value tells me. If you go back and you think about that bell curve for a minute, all right, if we go back here and we look at this bell curve, the middle value in that bell curve right here That value right there represents your average. So in this case, that first picture that we were looking at, what was the average for that class? 44.4. Okay. So their average score was a 44.4. One standard deviation away from there would be five units. So 5 units higher would be a score of 49.4, and 5 units less would be 39.4. All right. So between the scores of 39.4 and 49.4, I can guarantee to get 68% of all the kids in that class scored somewhere between a 39.4 and a 49.4. I'm sorry? So in a standard deviation graph, these percentages don't change. That's the breakdown of that. That's what the standard deviation tells me, is that I will get these percentages inside of there. Everything. Now, what would change though would be the mean for a class, or the standard deviation would change, meaning I might need a bigger number to get that same percentage, or I might need a smaller number to get that same percentage. Okay. And we'll see another class here in a second, and we'll see how their average changed, and then also how their standard deviation also changed. You're all right. The percentages here will never change. Okay. So one standard deviation will give you 68% of all your information on your graph. All right. What's up?
So for after the 49.4, would you add another 5 or would you add a
Yes. No. You would add one more standard deviation, or 10 would be from the beginning. Okay. So if we talk about being 2 standard deviations away, now you're talking about adding another 5 to here. Okay. So that would be a 54.4. And over here, it would be a 34.4. That would encompass somebody with a calculator. Add these percentages: 13.6, 34.1, 34.1, and 13.6. And actually, if we're going to be technical, this would be 68.2%. So what is it? What is it? 95.4. Okay. So for this class that you just were looking at, 95.4% of all their scores are gonna fall somewhere between a 34.4 and a 54.4. Now we know that the test was only out of how many points? 50. So really, these scores are probably not here, right? They're probably over here. And so then we can start to talk about how this picture, like just like a wave, may actually shift a little bit this way if the scores are a little bit lower, or may shift a little bit this way if the scores all are a little bit higher. Okay. We can do another one. All right. We could add another section out there. So this would be adding in another 2.1% to each side if we went one more standard deviation away. Okay. But what can change each time is that average and then the standard deviation. So here's what I'm going to ask you to do. We already know this one. This is for the first class. We don't know what that class's name was. Okay. Whoops. I would like you now to do this class. Okay. Now you can either go back to Desmos and delete everything out, or you can go back there and just go to box number 4 and start inputting information there. You just be careful. You make sure you know what your name of your group is up top for your table. It very well is going to say X2 and Y2 instead of X1 and Y1. So if it does, you just got to make sure you put in X2 instead of X1 when you're doing it. So you need a table. So pick a table. See how this one though says 2 in it instead of 1. So you're just, when you put in the mean and the standard deviation, you're going to need those numbers. You're going to need the labels to be x2s and y2s. You need a table. Is that the new one?
Yeah.
Oh, you already got them all in? Well, ain't you fancy? That was not what that was called. Okay.
Do you round up the standard deviation?
You would be told like 1 decimal place, 2 decimal places. I rounded the second groups to just 1 decimal place. And then the first one, I think it was 5.00 before a number showed up. So that's why we could just leave that one at 5. All right. How many of you guys have those numbers already in? You're good to go. Okay. So if we do that, then I'm actually going to come back here. And then in the new color, can you tell me what the average score for group 2 was? Kyler, do you have that? 38.6. Yep, that's what I had too. All right, 38.6. Hey now, go away. Like, go 38.6. Okay. What was the standard deviation here, Jack? 11.1. So a much higher standard deviation. Okay. 1 standard unit away. If I add 11.6 or 11.1 to this, what do I get for a 1 standard deviation away? You get what? 49.7. 49.7. And on the low side, what is it? 27.5. Yes.
So every time.
Go away. I can't see the numbers behind there.
Like even if you go up or down, you add the standard.
So as you go up, you add it. As you go down, you would subtract it.
And that's it.
Yep. Now, here's the thing though. Both of these are telling me the exact same information. I'm still getting 68.2% of all the information, but in the green, look how much more the span was than in the red. What does that tell me about these two classes? What does it tell me about the class in red? In red?
Oh yeah.
So in red, their average, and it doesn't necessarily have to be like, oh, well, your average was higher than the other average, so that's better. It's about how much span is taking place in order to gain the same information. Like if I was to take another 11.1 away from here, they're down to what, 16.4? In where in this class to get down 2 deviations away, they were still, almost, you know what I mean? Like 2 standard deviations away here was almost the same as their average. So the group in red, much more consistent than the group in green. Doesn't mean that the scores in green weren't still good. There were some good scores in green. Go back and look at it. Right. There's a 49.5. There's another 49, a 46. There's a 22 in here. There's a 10 in here. A 35.
Wait, are these like actual hours?
This is one of the classes. It's either second period, fourth period, 6, 7, or 9. It's one of them.
That's not 6, 7.
Okay. But, up here, the lowest score that I see, like 34, it's not great. Right? I mean, it's not great, but the consistency level up here is much higher, which is why their standard deviation is much smaller. Do you follow that idea of how that works? So it's in comparison to the individual score now today. All right. So in order to be able to really compare a standard deviation, you got to know 2 things. One, you got to know what the average is, and then number 2, you obviously got to be able to compute that standard deviation. And what does it mean? And so that is where this chart here comes into play. And like Kay said earlier, it has nothing, these percentages will never change. It's what values we get for an average in the middle, and then it's what standard deviations step from there. Okay? So I have one more that I want you guys to try. Okay, it's about Kyle. He's a baseball player. All right? All right? So here's Kyle. Kyle can throw with both hands. Can you? All right. So here's Kyle's pitches as a lefty and Kyle's pitches as a righty. Okay? So here's what I want you to do. Clear out whatever you got in your Desmos. Okay? Sure. Clear that out. And then one table for his left-handed pitches. These are his speeds. One table for his right-handed pitches. And then his averages. So his mean and then his standard deviation. And what does it tell me about Kyle as a pitcher? And then we'll be done. Okay? So clear everything else out you got in Desmos. What's that? Oh, you just can't see? Well, you move if you want to. You don't have to stay there. To another seat?
Closer?
There's nobody here. There's nobody there. I'll give you a rolly chair. You can go sit up there. It's got a broken armrest. I don't know what's going on with that thing. He's got that cheese, huh? I think it's cool to see people like switch gloves and pitch with it. That's crazy.
I saw this video, and Wilson like made this kid a custom glove.
Yeah.
Because he pitches both.
Yeah. I think the only requirement though is that whatever hand you start the at bat, you must stay that way the whole time. I believe. I don't think in the middle of an at bat you're allowed to say, I'm a pitch righty and then pitch lefty.
You have to strike him out.
But from batter to batter, I think you're free to choose which way you want to pitch.
Because you always want to pitch against the opposite side.
I think you want to pitch to the same side, I think, right? As a batter, you want to be opposite the hand of the pitcher, I think. I don't know. Baseball's not my thing.
A lefty goes against the right.
Yeah. Yeah. So we're looking for two things. What is the average or the mean for Kyle as a lefty? And what is the average or mean for Kyle as a righty? And then what's the standard deviation for each of those sets? And what does it mean about Kyle as a pitcher? So we're looking for 4 pieces of information here. Now I did see, Jack, you only opened one table and put, I'm assuming, in the X column his left-handed numbers and in the right column his right-handed numbers. You are absolutely free to do that. You just must realize of what label you're putting into your statistical function. So if you put them in the Y column, that's absolutely fine. What's that? So you have those pieces of information? Sorry. What? Okay. Does anyone have the average speed for Kyle as a lefty? Gracie, what do you got? 69.8. Can anybody else second that?
That's what I got. 60.
Okay. All right. So 69.7 miles per hour. Anybody have his standard deviation? How many of you are not there yet? Because if you're not, I don't want to. You're not there yet? You are there yet. Andrea, do you have this information in? I'm sorry, what?
I put the information.
So you have the standard deviation for him as a lefty?
Uh,
You just told me you did.
no, I mean I have the information.
You just didn't do anything with it.
Yeah, because I don't know.
You have it all put in?
Yeah, this is my left.
Okay. So that's titled X1.
Yeah.
So come down here till you have an open spot. So down here. Is that it? There we
Yeah.
go. And then pull your computer up and go to function to statistic. And we want the mean. So the mean of X1, because that's what it was called.
Okay.
So that's where that number, that 69.7 came from. It's up there on the board. And then go to the next open function spot and go back here. And then we're going to choose the standard deviation, which is the third one. And again, we'll do X1, and that's the number that we get.
Oh,
Okay? All right. So the standard deviation for a lefty, Andrea, is what? 2 point something, right? 2.27. Perfect. All right. Now let's go to the right-handed person. So, Andrea, if you have that as another table, it's probably labeled X2 and Y2. So you do the exact same thing that we just did, except instead of saying X1, you would put in an X2. All right. Can somebody give me the mean for his right-handed pitches? Jack, what do you got? 76.1? Okay. So miles per hour again. And his standard deviation there, Lily, do you have that? 5.43. All right. So knowing that information now, what do we say about Kyle as a pitcher? What do we say? So he's statistically faster as a righty. I would agree with that statement. What else could we say? Okay, so what makes you say that his consistency level drops off as a righty? Okay, so the standard deviation for his right-handed pitches is higher than it is for his left-handed pitches. All right. So his span, if we would go back to this chart, in order to get 68% of the information, here I got to go almost 5.5 units in both directions for a righty. But for a left-handed pitching, I only have to go a little more than 2 units in both directions to get that same amount of information. Does that make sense? The lower the standard deviation score, the more consistently grouped those values are. Okay? And again, it's not all about the mean or the average. It's okay for one to be higher than the other. Here, as a righty, dude's a little wild. He might throw some heat, right? But then the next one doesn't have it, or who knows where it goes. Maybe it's in the dirt. I don't know why it's slower. Okay, but there's much less consistency out of his right hand than there is out of his left hand. Okay, so as we look at that standard deviation value, that's what we can start to determine about these points. What's up?
Do you want us? I did the thing where,
Excuse me?
like how we did up there.
For what? What are you talking about?
I did the numbers where you added.
Oh, yeah. So I put those on this graph here because I wanted you to see how those breakdowns were going to change depending on what's the average and what's that deviation. Okay? Most of you probably just have a couple questions left on that paper to finish up for tonight. Some of you may have a little bit more. I don't know if you noticed or not, though. One of the functions inside of the calculator also does have that MAD button, which would be the mean absolute deviation. So that is also something that we can calculate on the computer as well. Okay? All right.